In this video, I'm going to go over a force problem. So in this problem, a 20 kilogram box is pulled with a force of 80 newtons at an angle of 45 degrees at a constant speed of zero point 0.4 meters per second across a frictional surface. And the question is, what is the kinetic coefficient of friction? Okay, so here we've got a block. Whoops. Here we have a block that is 20 kilograms, and it's being pulled across a frictional surface with a force of 80 newtons and an angle of 45 degrees. It's moving with a constant speed of 0.4 meters per second. What is the kinetic coefficient of friction? And so remember, with friction, it's kind of two types: static and kinetic. In this problem, since the block is already moving, we are dealing with kinetic friction. Okay, so to start this problem, first draw a free body diagram and work your way from there. Okay, so the free body diagram for this block. So as always, we have the force of gravity. Table is horizontal, so the table exerts force on the block, force normal. Here we have an applied force that is 80 newtons. And this is at an angle of 45 degrees. And because the block is moving in this direction, we have friction forces in this direction. Now, the next step is kind of to divide your forces in the y and x direction. And the reason we'll do that is we'll set up an equation of the net force in the x direction and net force in the y direction. So here for this applied force is a vector that is at 45 degrees. So it has a component that's in the x direction and in the y direction. So I'm going to call this right here F A X, and this part right here F A Y. So you have this vector, and you can almost kind of think of this as a triangle. So this is like your hypotenuse right here, and this is 80 newtons. And then the y component is on the opposite side, and this is the x component. And so basically for this, to find these two components, you're going to go back to trig and your sine, cosine, tan. So kind of what they teach in schools is SOHCAHTOA. So for FAX, we were cosine of 45 here is adjacent over hypotenuse. So this is the adjacent side. So that is equal to FAX over our hypotenuse, which is 80. So the x component of the applied force will simply be 80 cosine of 45. Similar, sine of 45 will be the FAY over 80. So if we rewrote that, it will be 80 sine of 45. And again, if this is does not come easily, go back to trig and review sine and cosine. Okay, so now what we'll do is we'll start off in the x direction. So the two forces in the x direction are a friction force and FAX. Now, what I like to do is that to be consistent with signs, I will always have everything pointing in this direction positive, and everything that points in this direction as negative. Same with up and down. Anything that's pointing up, I consider positive force. Anything that's pointing down will be negative. So here, my two forces in the x direction, we've got applied force in the x, which is positive, minus our friction force, and that is going to be equal to m acceleration in the x direction. Now in the y direction, we've got three forces. We have F-A-Y plus F-N minus F-G equals M-A-Y. Now in this case, the block is only moving in this direction. So right there, we already know that it's not accelerating in the y direction, so the sum of these three forces will be 0. Now in the x direction, we know that the block is moving at a constant speed at 0.4 meters per second. So what that tells me is that my acceleration in the x direction is also 0. So this will be 0. So I know that my applied force in the x direction will be equal to my friction force, which is equal to 80 cosine 45. On this side, I know my gravitational force is mg. This is equal to mg, and I know the mass of my object. So on this side, I can solve for my normal force. So here I've got plugging in this expression for FAY, 80 sine of 45 plus Fn minus mg is equal to 0. So Fn is equal to 20 times 9.8. Bring this to a minus 80 sine of 45. So if we put that into our calculator, we get 128. So our normal force is 128 newtons. Alright, I'm going to write that up here. Equal to 128 newtons. Now going back to here, the question was asking for the kinetic coefficient of friction. And I know that the friction force, just realized that this value, realized that I was on the, so in your calculator, another thing to note, that when you're doing these problems, you want to make sure in your calculator that you are in degree mode. One thing I always like to do is I'll do either sine, I know sine of 90 is 1. And so when that, that's a way to check that you're in the correct mode in your calculator. And so I'll do that calculation again. This should actually, the normal force will be 139 newtons. And so degrees, you always want to make sure the mode of your calculator is in degrees and not radians. And the way to check that is either to do quickly sine of 90 should always come out to be 1, or cosine of 0 should come out to be 1. Kind of a couple of easy checks. Okay, so back to here. So then I know that my friction force is equal to 56.6 newtons. And from the formula, I know that this is equal to mu times the normal force. And so here I can plug the normal force that I solved on the y side into this equation and then solve for mu. So 56.6 divided by 139 gets you mu of about 0.41. So our kinetic coefficient of friction is 0.41. And this value, your coefficient of friction, should always be less than 1. So if you get a value that's greater than 1, that tells you that somewhere in your math you did wrong. So to recap, the kind of first step is to draw your free body diagram with your forces. And any component that's at an angle, you want to split up into an x and y component. Then you'll do your sum of the forces in the x direction equals mass times acceleration in the x direction. Then you'll do the sum of the forces in your y direction is equal to mass times acceleration in the y direction. And then typically one of these accelerations will be 0. And if you're at rest or moving at a constant speed, then both these accelerations will be 0. And problems that usually involve friction, you'll solve for the normal force and then plug that back into your friction force. Okay, thanks for watching.